Hello everyone. In this video, we are going to understand about the trapezoidal rule or the trapezoidal method. So this method is an example of a numerical integration method. So we will take a working example to understand this method, and at the end of the video, we will see that how we can implement this method using a C program. So let's start. Now before moving to the trapezoidal rule, let's understand some of the basic things. So you have studied this in your plus 2 classes that what is integration? Integration is a method to find the area under the curve fx and the x-axis between 2 points, let's say A and B. So here you can see you have the fx curve and here you have the 2 points A and B. So the area, that is this area, it is the integration of this function fx under the point A and B. Okay, so this is the meaning or the physical meaning of the integration. It gives us the area between the curve fx and the x-axis between the 2 points, and it is denoted by this way: fx integration between A and B. Now next thing is, what is numerical integration? So actually sometime it may happen that if we integrate this function fx, then we may not get some known function or the function which is a closed function. So at those points or in those scenarios, we use numerical integration. So numerical integration process will also give me the integration of this function between 2 points A and B, but it will always give me a simple value, okay, or numerical value. Whereas the integration that we have studied in your plus 2 classes, in that whenever we integrate this function fx, we will get some a function, okay, and then we can find the answer by putting this A and B limit. But in numerical integration cases, we will get a simple numerical value. So before moving to the numerical integration methods, let's understand how these methods work. So numerical integration says, let's say you have this function fx and you have to find the integration of this fx between the A and B point. So what you will do, you are essentially dividing this A to B interval into small intervals. And how many intervals are there? There are n such sub intervals. That means you will divide this A to B interval into n parts. Okay, so there will be n intervals between this big A and B, and all these intervals will be of length h. Okay, so this h or this length of the interval is also called as your step size. Okay, so in this way your numerical integration methods works to find the integration of a function between 2 points A and B. So these are the different numerical integration methods: trapezoidal rule, Simpson 1/3 rule, Simpson's 3/8 rule, and Vidal's rule, and Boole's rule. So all these formulas are actually the special form of a formula called Newton-Cotes formula. Okay, so this is just for your knowledge. Now we will see in this video that how this trapezoidal rule works. Okay, and in the other videos we will understand that how these other methods works. So before going to the trapezoidal rule, let's understand what is the basic thing that is behind all these rules. So as I told you, you have to divide this A and B interval into n sub intervals, and each of these interval is of length h, right? And these h are of equal size. Okay, so you can say that this point A will be called as x0, this will be your x1, then this is your x2, and so on. So last, this point will be your xn. Now corresponding to this A point, we have this value which is cutting this fx. So this will be treated as this y0, this will be treated as y1, this is y2, and so on. So last will be your yn. Okay, now normally when we apply the numerical integration method, then as the input in the question we are given the some of the values. For example, we are given the function for which we have to apply the numerical integration method, and the limits or the point A and B, and the third thing is given that in how many parts or how many sub intervals we can divide this limit A and B. Okay, that is we are given the value of n. Now by these values we have to find actually the value of h. So how you can find the value of h using the A, B, and n? So as you can see here, we have the function fx and 2 points A and B as 2 and 22. the number of subintervals is given as n equal to 5. That means we have to divide this complete, this is b actually, this is not b. So we have to divide this complete a and b, that is 2 and 22 size, into n equal to 5, that is 5 intervals. So this is your first interval, second, third, fourth, and last is fifth. So then if you are asked what is the value of h, that is what is the interval gap, so you can easily find out. How? You can just find the length of this interval from a to b. How? You can just subtract 22 minus 2 and you can divide this by 5, that is n. Then you will get 4 as the interval size, that is value of h. So that means the formula for h is b minus a upon n. So with all these knowledge, let's understand how this trapezoidal rule works with a working example. So here is the question. We have to evaluate this, that is we have to evaluate x cube between the limit 0 and 1. So the 0 is the lower limit, 1 is the upper limit. So we have to evaluate this integral and using trapezoidal rule. And this is given in the question that we have to divide this 0 to 1 limit or 0 to 1 range into small intervals. And how many intervals in which we have to divide? It is 5. Okay, so we have to break down 0 to 1 range into 5 small sizes pieces. Okay, so this is the formula for the trapezoidal rule. If we have to integrate fx between this a and b, the formula says h by 2 multiply, you have to find the sum of y0 and yn, then plus 2 multiply the sum of all these terms. So what was this y0, y1, y2? We had seen that this is the function fx and this is the a and b point. So this point on the x-axis are x0, x1, x2 and so on. Okay, and these are the values at the x0 point for this fx function, which is called as y0, y1, y2 and so on till yn. So these y0 to yn values we have to use in our formula, and we have to use h also. That means to find the integration between a and b, we have to find these values of the y and value of the h. So let's see how we will proceed with the trapezoidal rule. So in this question, we are given the value of a, b and the n is this, and we are given the function also, that is x cube. Now we have to find first the value of h. So the formula for h is b minus a upon n. So value of b and a is 1 and 0, 1 minus 0 upon n is 5. So after evaluating this, we got h 0.2. So this is the interval size or the step size. So as we saw in this formula that we have to find the value of h and the values of various y's. So we have find the value of h. Now we have to find the value of these y's. Now the question is, to find the value of y, we have to put some values of the x, that is x0, x1, x2 in this given function. Then only we can find the values of the y0, y1 and so on. So how we will find these x0, x1 and x2? So you can see here this x0 is equal to a. And what is this x1? So this x1 can be written as a plus h. H is this interval size or the step size. Likewise, what is the value of this x2? You will say this is h. Okay, so this x2 can be written as a plus a means this one, and this h plus h will be 2h. Likewise, the last value, that is xn, it can be written as a plus n into h. Okay, so this way we will find the values of these various x, and then we can easily find the values of y0 to yn. So we will write all the values of the x and y in this tabular form. So what is the initial value? That is, we have to find this x0. So x0 is equal to a only. Okay, so this is 0. Now we have to find x1. So x1 is this value of a plus this h. So 0 plus 0.2. What will be it? It will be 0.2. Now x2 will be your initial value of a, that is 0 plus the multiplication of 2 into this, that is we have to add this h 2 times, that means it will be 0.4. So it will be 0.4 and so on. If we find the other values, we can easily find. So these are the other values of the x. Okay, all these values are in the gap of 0.2, that is this interval size. Now we have to find the various values of the y, that is y0 to yn. So how we can find these values? we have to use this function f of x, which is given to us. So this fx is actually y. Okay, so we can write as, if we have to find y0, that means we have to find function value at x0 point. So that means we have to put x0 in this x cube. And what is x0? It is 0. So 0 cube will be 0. So this is your 0. Okay, now we have to find y1. Y1 mean function value at 0.2. So 0.2 cube will be 0.008. Likewise, we can easily find the values of y2 to last yn. This is actually y5. Okay, so y2 will be function value at x2 and it will be 0.4. This is 0.4 whole cube. So this will be 0.064. And likewise, we have found the other values of the y's. So I have written all the values of the y also here. So these are the values of the x and the y's. So now we can use all these values in our formula as needed. So let me write all these values in a more clear manner. So these are the values of the x and the y that we have calculated. So this fx is actually your y. And these values are your y0, y1, y2, then y3, then y4, and so on till y5. Now let's apply the formula. So as you can see in this general formula, we have h by 2, then we have the y0 and yn. So this y0 is the first value of the y and this yn is the last value of the y. Then the remaining values, they are actually added y1 to yn minus 1 and then they are multiplied with 2. And all these answer, okay, this is finally getting multiplied by h by 2. Okay, so let's see how we will use in our example. So as we have seen the formula, these y0 and y5, these are the first and the last value of the y. Okay, then plus 2 multiply all these values. Okay, y1 to y4. So this is y1 plus y2, y3 plus y4 multiplied by 2. And then whole is multiplied by h by 2. Okay, so let's put all the values of these y's. So on putting all these values of the y, we got this. Okay, so now if we solve this whole complete formula, we will get 0.26 as the answer. That means after integrating this x cube from 0 to 1 using the trapezoidal rule, we will get the numerical value as 0.26. Now here one thing to note is, if you want to integrate this x cube from 0 to 1 using the formula that you have used in your plus 2 classes, then what value you will get? As you know, the formula for the integration is xn dx from a to b is x to the power n plus 1 upon n plus 1. So if we put this formula here, then what value we will get? It will be x to the power 4 upon 4. And after putting the limits value, we will get 0.25 as the answer. And here by numerical integration, that is by trapezoidal rule, we got 0.26. So actually we got the similar type of values between our trapezoidal rule and the normal integration. So the trapezoidal rule or the numerical integration method, they give us the approximate values. Okay, so this is your trapezoidal rule and it is how it works. So just to recap, you are given the values of a, b and n and the function. So first you have to find the value of the h, and then using the value of h, you find the various values of the x, and then to find the values of the y, that is the function values at these x0 to x5 points, you use the function. And after computing all these values of the y, you apply the formula and you got your answer. So this is a simple method. Okay, so I hope you have understood that how we can apply this trapezoidal rule. So now it's time to understand that how we can implement this in a C program. So let's understand the algorithm and the pseudocode and the implementation part using a C program. So as we have seen just now, we will be given some values, the value of a, b, and then n, and then function value, and then we have to find the value of h, and after that we have to apply the formula by finding the values of y0 to y1 to last yn. Okay, so this is actually yn. So accordingly, we have to first ask the user the value of n, the values of a and b, that is the upper and the lower limit. Okay, now we have taken this function value directly in our program. Okay, we will see that, for example, this function is x cube, then we will directly write this function in our C program. Okay, so we are not asking this function from the user. That's why I have not written, or I have not taken this function as the input from the user. So after finding, or after getting all these values from the user, we have to find the value of h using this formula. So this is b minus a, and this is your n. Okay, now next thing is we have to find the values of y0 to yn. Okay, and after that, what we will do, we will apply the formula and then we will print the result. And this is the formula for the trapezoidal rule. So this thing is very simple. You can just ask the user all these values of n, a and b using just scanf in a C program. Okay, the thing is, you can also find this value of h also. It is a direct formula. Okay, now the question is how we have to find the values of y0 to yn and how we will apply the formula. So these points are the main points, okay, that we will see. So you know that to find the values of y0 to yn, you need first the values of x0 to xn, so that you can put all these values into your given function, and then you can find the y0 to yn. Okay, so there are actually two ways to apply this trapezoidal rule. Let's see what are those ways. So this is our first method. In this method, we have used two arrays. One array is storing the value of x, and another array is storing the value of y. So these are our x values, 0, 0 0.2, 0 0.4, and so on. And the values of the y are these fx values, that is 0, 0 0.008, and so on. So you can see here that how many values are corresponding to x and y. So corresponding to x, we have total 6 values, 0, 0 0.2, 0 0.4, and so on till 1.0. And the same, we have the 6 values corresponding to fx or the y's. Okay, so currently we are having the value of n, that is number of sub intervals, equal to 5. But we need to store 6 values for the x and for the y. That means we need arrays which are having the size as n plus 1. So n is 5, so 5 plus 1, 6. So the size of the array x and y will be n plus 1. Now to store the values of the x in our array, we will use a loop. So here you can see that I have taken a loop to store the values of the x in my x array. Okay, and after that I will store the values of the y in my y array. Okay, and to calculate the value of the y, I will take the help of a function f. Okay, so let's first see this loop. So here what I am doing, as I have to store how many values, total 6 values. So I am starting from I equal to 0 to I less than equal to n. So n is my 5. Okay, so as loop is starting from 0, so my values will be like stored from the index 0, then 1, then 2, and till 5. Okay, so total 6 values are stored. Now this is xi. So xi will be like x0, x1, x2, and so on till x5. Now here these are the values which have been calculated for the x. So here you can see that this 0 was actually a, and this 1.0 was actually b, and these 0.2, 0.4 all are at the gap of h. That means this 0.2 is actually a plus h. So a is 0, and what was the value of the h? We calculated as 0.2. Okay, so this a plus h will become as 0 plus 0.2, that means 0.2, and 0.4 was actually again at the gap of h from this 0.2, but it was at the gap of 2h from this 0. So 0.2 can be written as a plus twice of h, that means 0 plus twice of h means h is 0.2. So this is your 0.4. So this is your 0.4, and so on. So you can see that this last value 1.0 can be calculated as, let's say, a plus then nh. Okay, so a is 0, but what is the value of n? N is 5, and what is the value of h? It is 0.2. So this is 1. Okay, so this way last value can be calculated. So in this way I have applied the same thing here, a plus I into h. See, h is constant, a is constant, this I is varying. What is this I? So here this is a plus h. So
the it can be written as a plus 1h, right? Here it is a plus 2h. So this 2 is actually I. Again, this can be written as a plus 3h. So this I is corresponding to your 3. So this I is starting from 0 initially. Why? Because this A can be written as A plus 0h. So the initial value of I is will be 0 and the last value of I will be your n. Okay. So this is A plus I into h. That means it will be A plus 0h. Then in the next iteration, it will be A plus 1 into h. And at the last, it will be A plus n into h. In this way, all the values are getting stored inside your X array. Now coming to your Y array. Now all the values that I have calculated from this first loop, I am using in calculation of the Y's. Again, I have to calculate total 6 values. That is, my loop is starting from I equal to 0 to n. And how I can calculate the values of the Y? So Y can be calculated using the function f. Okay, so here I have taken the function. This function f is taking a parameter float x, and this x value will be put inside our this function, that is x cube, and answer will be returned by this function which is of type float. So what I will do, this function is passing the argument as xi. That means for I equal to 0, my x0 will be passed to this function. X0 is this 0. So it will be, for the first time, f of 0 will be calculated. F of 0 will be given by this function and it will be stored inside y of i. Next iteration, I equal to 1, my this will be your x, and then this x of I, that is x of 1. So what is the value of x of 1? X of 1 is 0 0.2. This is 0 0.2. So essentially 0 0.2 will be passed from this function. Okay, so function value at 0 0.2, this formula will give me, or this function will give me as this 0.008. So this will be saved inside y of I, and so on till I less than equal to n. So all the values of y are getting stored by this loop. Okay. So in this way, I have stored all the values of x, all the values of y in the two arrays, x and y. Now the third thing is we have to apply the formula and print the result. So we can see that the formula is very simple. It is like the addition of the first term and the last term. Okay. And after that, we can just add all the remaining values from y1 to yn minus 1. So this is simple, like you just add in a single line y0 plus yn. Then you can just use a loop to add all these values y1 plus y2 and so on. And after that, in single line, you can just apply the formula as like h by 2 into, let's say, this y0 plus yn is stored inside x, let's say, or let's say some another thing, you can take it as, let's say, p. Okay, then p, and then plus 2 multiply, let's say this loop value is getting stored inside, let's say, in some another variable as q. So this can be stored inside q. So you can just use this single line in your C program and you can just calculate the final value of this integral. Okay, so that would be like taking how much time? O of n, because I have to traverse the values of the y. Okay, now if we talk about the space and time complexity of this code, then space complexity will be O of n. Why O of n? Because I am taking two extra arrays, x and y. So this is of order of n, this is of order of n. So two extra arrays I am using to store the value of x and y. So space complexity will be order of n. And the time complexity will be again order of n. Why? Because I am running this loop how many times? N times. Okay, so this is order of n complexity, and this loop is also running order of n times. And when we will apply the formula, again we have to traverse this whole array of the y so that we can apply the formula. So that will be of order of n. So all will be like order of n plus order of n plus order of n. Total will be like order of n, although there will be a constant, but that will be okay. The total complexity or the time complexity will be order of n. Okay, so this was our first way. Now in the second way, we will see that we will change, or we will convert this space complexity to the order of 1. That means we will not take any extra space, and our space complexity will be order of 1. Time complexity will remain as order of n in our second way also. So let's see what is the second way and how it is getting optimized.
So we will directly be computing this y0 to yn values, and we will directly be using them into our formula. Okay. So I will not be using any extra arrays, that is x and y arrays. Okay. So let's see how we can do that. So essentially what we have to do, we have to actually apply this formula, and now it is up to the user that how he can implement this formula. Okay. So what we will do, we will take a function into our C program, okay, that I have told you. This is your actually f of x. We have the function float find value at, and x value will be provided to it, and then we will be computing the value of the y corresponding to x. So this formula is something like we are providing x0, and then it is giving me y0. When I will be giving this 0.2, that is x1 as the input, then it will be giving me y1, that is this value, and so on. Now in the formula you can see that these two values are actually holding some unique value. What is the unique property or the unique value in them? So this y0 is the initial value corresponding to this x0, okay, and what is this y5? This y5 is the last value, that means corresponding to your 1.0, or you can say corresponding to b value, and these are the remaining values. Okay, so I will be writing this code. What is this code? So this is actually your sum of two values. So find value at a. So this is actually your y0. You know, you will be given in the question a as 0 and b as 1, as we have seen in our example. Okay, at a point we will be finding this answer, and similarly we will be finding the value of the function at b. So this will be giving me the y5 in our given question. So this addition of y0 plus y5 we have calculated, and we have stored inside this sum variable. Okay, so this is stored inside sum. Now in the next process, we will find this y1 to y4 values sum. Okay, and this is the code to find the sum of from y1 to y2, y3 and y4. So for this we have used a loop. Why we have used a loop? Because we do not know how many values we have to add. Because for this example, there are y0 to y5 values, but if the interval size or the number of intervals, they are more than 5, let's say they can be like 20, then you will have many values of the y, and then it will not contain only these values from y1 to y4. It will contain many values after this y4 also. So we have to add them again and again. So for that, the best way is use a loop. So after finding this sum by this line, and after finding this sum using this loop, what we will do, we can just add them. Okay, add these answers and then multiply by h by 2. And what I will do actually, I will add this complete answer directly inside this sum. Okay, here you can see I am writing sum equal to sum plus. So let's see how we can do that all this. So currently we have some values as y0 plus y5, that is this answer. Now here you can see I have to add this y1 to y4, and who can give me this y1 y2 values? There is a function find value at. This will give me those values. Okay, so you can see here inside this loop I am saying sum equal to sum plus 2 multiply this find value at. So actually what I have done, I am saying that you can rewrite this to multiply this whole thing as 2 into y1 plus 2 into y2, 2 into y3 plus 2 into y4. Yes, you can write this way also. So I have used this thing here. So what I am doing, firstly, we have to start from your which value of x? X1, and then x2. So at x1, we have to find y1. So this find value at I is giving me those values of the y. So what should be the initial values of the I? It should be x1. Okay. And what is this x1? This is 0.2. And how we can calculate this 0.2? This is actually a plus h. and this is a. Okay, the same way this 0.4 was a plus 2h. Similarly, this is a plus 3h and this is a plus 4h. That is, I have to start from a plus h and I have to run a loop before this b. That is, I will run till a plus 4h. So the same thing I have written as from a plus h I am starting and I am running this loop till I is less than b. So you can see this I as this x values, various values of the x, x1, x2 and so on. So I am generating the x1 and x2 from this I, okay, and then I am using those here. So for the first time I will be a plus h, that is it is 0.2. So for the first time I am saying the previous values of the sum plus 2 multiply this find value at, I'm writing this as f, okay, for the time being, f at 0.2. okay, so f at 0.2 will be your this value, okay, 0.008. Then 2 multiply this will be your sum answer and it is added with the previous sum. Okay, so what we are doing, y0 plus y5 was the initial values inside this sum. Now we are storing this 2 multiply y1, okay, inside this sum. Okay, now after that I will generate the new value of the I. What should be the new value of the I? It should be 0.4. So what I am saying, I equal to I plus h. Okay, so this means the previous values of the I was 0.2. Now if I add more h, that is plus 0.2. Okay, this is the value of the h step size. It will be 0.4. Okay, so new value of the I or the x is 0.4. Now I will be using this 0.4 here. Okay, so at 0.4 I will be finding this 0.064 and I will be using here as 0.064. So it will be like previous values of the sum. Okay, that means this answers and plus 2 into y2, that is 2 into this value. Okay, so in this way we have calculated this thing also. So in the same way we will calculate this answer and this answer inside this loop. So all these answers are getting saved where? So they are actually getting saved finally into your sum. So we are directly adding these values inside your sum. So finally the sum contained this whole answer, right? So finally you will be multiplying this with this h multiply sum by 2. What does it mean? You can simply write it as h by 2 multiply sum. Okay, this formula h by 2 multiply sum. Okay, in C programming you can also write it as h multiply sum, then whole answer as divided by 2. So this answer will finally be getting saved where? Inside again sum. Okay, or you can use another variable, but it is okay. So this way we have found the total answer inside your sum, and this is the answer that we have to print. So you have seen that we have not used any extra array, okay, to store any value of the x and value of the y. So this is the optimized version to apply the trapezoidal rule. So I hope you have understood this code. So let's see the C program for this trapezoidal rule. So this is the C program to implement trapezoidal rule. So here you can see I have taken a function find value at, and this is the same function that we have used in our pseudocode. Okay, so this is your like x cube, the function. Now in the main, what we are doing, we are first asking the user the values of the a and b, that is upper and the lower limit, then how many number of intervals you want to use or break your the range of the a and b, that is value of n, and after taking these inputs we are doing the computations. What is the computation? So first you have to find the value of h using this formula. Then this is the same code that we have just discussed. We find this sum and then we use the loop, and then we have found the direct or the and then we have found the final value of the sum. Okay, and this is the sum that we are printing, that is the value of the integral. Okay, so let's run this program and see what is the output that we are getting. So I will enter the value of a and b as 0 and 1 as we have seen, and the number of intervals is 5. Okay, so here you can see we are getting the same value 0.26. Okay, I hope you have understood how the C program will be used to implement this trapezoidal rule. So if you have any comment, query, suggestion, please write down into the comment box. And if you have not understood anything in this trapezoidal rule, you can write down into the comment box. And do like and share this video. Please subscribe the channel and press the bell icon for further notification. See you in the next video. Till then, goodbye.